Evolution of the Earth's atmosphere. We're going to today learn how the Earth's atmosphere evolved and how the composition of the gases in the air changed. So what you have to understand is that the Earth obviously is very old. It was 4.6 billion years. Now, at the very beginning, the Earth, for the first kind of 1,000 million years, it was covered in these volcanoes. Now, these volcanoes, a little bit like in Mars, basically, imagine like Mars. Full of volcanoes, really hot, really aggressive, no water, no nothing except loads of volcanoes. Now, the volcanoes released a lot of carbon dioxide. There was virtually no oxygen, essentially. Volcanic activity also releases N2, nitrogen, as well as the small traces of water vapor, because obviously it's a combustion reaction, methane, CH4, and ammonia, NH3. So these were the main gases present at the beginning. Nitrogen and carbon dioxide with small amounts of water vapor, methane, and ammonia. That is phase one. Now, phase two. First main thing you need to know is why the carbon dioxide decreased. Well, the way the carbon dioxide decreased is that the water vapors, as the Earth cooled down and volcanic activity stopped, and the Earth cools, the water vapor condenses, and that's how the oceans were formed. So that's how we got all that water on Earth. Now, the carbon dioxide is water soluble. So what happened is the carbon dioxide went and dissolved into the oceans. So it started to decrease. Okay. When it dissolved in the oceans, it sometimes formed carbonate precipitates, which are sediments on the seabed that contain carbon dioxide. So that's the first two ways. Then the second way is through green plants. So when the green plants evolved, which actually is phase three, they started to obviously photosynthesize and take in carbon dioxide and release oxygen. Also, marine animals that later evolved, their shells contain carbon in them. So when they died and when they became, when they turned into rocks and fossil fuels, they stored the carbon dioxide in it. They stored the carbon. So when an animal dies, it falls on the seabed and gets buried by sediment. So when it gets compressed at a high temperature and with a lack of oxygen, it essentially turns to crude oil. Okay. And these fossil fuels would have a lot of trapped carbon in them. Obviously, limestone is another rock that contains calcium carbonate deposits, so it will have a lot of carbon trapped. And coal is a sedimentary rock that contains carbon in it from plant deposits. So overall, why the CO2 decreased, there's three reasons. It dissolved in the oceans, it got locked up as sediments and carbonates on the seabed, and it got decreased by photosynthesis of green plants. At the same time, that's how oxygen increased, by the photosynthesis. So it was about 2.7 billion years ago that the algae first evolved to make the oxygen. Once the oxygen was sufficiently built up, so at Earth today there's about 21%. When the oxygen increased, more complex life forms were able to form. So that's the main gist of it. The next bit is how did the nitrogen increase? That's the only thing not really mentioned here. So the nitrogen was already present from the volcanoes. But the way nitrogen was released was by these denitrifying bacteria. Okay, so nitrate ions in the soil were by denitrifying bacteria, they released nitrogen. And furthermore, one more thing happened that's very important, is that ammonia, NH3, that obviously is an unpleasant gas and does not exist in the atmosphere today. That reacted with oxygen to form nitrogen plus water. Okay, so if we put a 2 here, 3 here, and a 1.5 here. That is how nitrogen was formed when ammonia combusted with oxygen. And the methane, also a very flammable gas, is not present, thankfully, in the Earth's atmosphere. That turns to CO2 and to water by combustion. So you put a 2 here to balance it, and a 2 here. So that is the way methane decreased. And that is the way ammonia decreased and how nitrogen increased. So beware of this reaction. So if I summarize it before moving on, at the beginning there was loads of CO2, water, and loads of CO2 and nitrogen and water vapor traces. The water vapor condensed. Yeah, so to summarize, the volcanoes, they released a lot of CO2 and nitrogen, and there was traces of water vapor. The water vapor condensed as the Earth cooled down, and it formed the oceans. And then the carbon dioxide was able to dissolve in the oceans. So, 1 second. It should be here. Yeah, so you can read through it. I mean, there's a lot of information. I've been over the key points. The carbon dioxide dissolved in the oceans. They became locked up as sedimentary rocks on the seabed. And they also were, CO2 was reduced by photosynthesis, which also produced oxygen. Now, just to show you these equations that I was telling you about before, that's the reaction I was talking about. Ammonia decreased by reacting with oxygen. That's how it was removed from the atmosphere. And methane was removed in this way by burning. And the good thing is we're full of nitrogen now, which is highly unreactive. One thing for you to be aware of, obviously today's atmosphere was done in a separate lesson, but it is 78% nitrogen, 21 oxygen, and the rest is the argon at 0.9, CO2 at 0.04, and water vapor at around 0.06, depending on conditions. What you need to be aware of is, I'm going to show you an exam question that kind of really summarizes this very well, okay? And I would actually learn from this mark scheme directly. Let me show it to you. So the exam question is as follows. It's from an old paper. I'll just show it to you like this. So forget about being assessed on your good English. Focus on this. Describe and explain how the surface of the early Earth and its atmosphere have changed to form the surface of the Earth and atmosphere today. And they show you how here it was mostly CO2 and water vapor, and now it's mostly nitrogen and oxygen. So you have to explain how this one decreased and this one, and how these two increased. And you have to explain it, not just describe it. So the mark scheme goes as follows. Really good to understand this. This is like a very perfect summary. In fact, I'm going to screenshot it. So this is the best summary. Oxygen increased because the plants used carbon dioxide for photosynthesis. Carbon dioxide decreased as it dissolved in the oceans when the water vapor condensed. Carbon dioxide locked up in sedimentary rocks or fossil fuels. Obviously, it's not in order. The oceans formed because the water vapor cooled and condensed. Then here's an extra point. The continents formed because the Earth cooled, forming Pangaea, which is a supercontinent, which then separated into its different continents. And the volcanoes reduced because the Earth cooled down and formed the crust. Nitrogen formed because ammonia reacted with oxygen and because of denitrifying bacteria. So these are the two that I covered earlier. With that, it brings an end to the lesson of the evolution of the atmosphere. So thank you for listening, and see you next time.